Okay. In the beginning of probability, we talked about the three different approaches to probability. We said there was classical, like the ideal world, what we've been doing, you have formulas, and then we talked about subjective, which is your own personal opinion, and the last one was relative frequency. And we said relative frequency is often used when you don't know a probability. You try to simulate that thing happening over and over again. That's what we're doing today. Let's say we don't know how to calculate a probability. How can we simulate that happening to estimate a probability? So what we're going to do today is we're going to design simulations and then carry them out. So, simulation, often used when you cannot calculate a probability and hopefully you remember the one thing I said was really important about the relative frequency approach was the law of large numbers. And what did the law of large numbers say? Anyone?
More tests, more accurate.
Yeah. More trials you have, the closer your estimated probability will get to the true probability. So when you are designing a simulation, first thing that you have to do is you have to assign digits. Designing a simulation is going to be very, very similar to choosing a simple random sample. So do you guys remember when you chose a simple random sample, you either used a table or a random number generator? Do you remember how every individual had to have the same number of digits? Right? So assign digits, everything has to have the same number of digits. And then you're going to tell me how you're going to use a table or a random number generator. You have to be able to do both. You have to tell me, are we using replacement? That is probably going to be the trickiest part here, is the replacement. If you remember before, oftentimes we didn't use replacement because you didn't want to choose the same person twice. Now things are going to change a little bit depending on context. Fourth step, what is your stopping criteria? So when do I stop? What do I know is one trial? How do I know I've gone through one trial? And then lastly, you need to make sure that you answer the question. So we're going to do a few examples where we carry this out. Quick reminder for you, you need to be specific enough. That I could actually carry out your design. And not only me, but if I carried out your design and then Mr. Plate, the other stats teacher, carried out your design, we would carry it out identically. Okay, questions before we look at an example? Okay. A basketball player makes 70% of her free throws in a long season. In a tournament game, she shoots 5 free throws late in the game and misses 3 of them. The fans think she was nervous, but the misses may simply be chance. You would like to address the nervousness issue by estimating the probability that she misses 3 or more. So before we even design a simulation, I want to talk about why it's necessary. If we tried to calculate this, we would calculate the probability that she misses at least 3, which would mean she had to miss 3, or she had to miss 4, or she had to miss 5. Now, theoretically, you might be able to calculate this, but we haven't technically learned it yet. So if she misses 3, do we know how to calculate that? Any ideas? The issue is if she's shooting 5 times, do we recognize that those 3 misses could happen many ways? She can miss the first 3, the last 3, the middle 3, and so on and so forth. Do we see that this is really tedious then? without a formula or something more helpful. So hence why we wouldn't do it that way, and we're going to do a simulation instead. So here's what we need to simulate. We need our simulation to be one where 70% of the free throws she's going to make. So for my simulation, I'm going to say let the digits 0 through 6 denote a successful free throw, which means 7 and 9 are misses. We are going to start at 101 on the table. And look at one digit at a time. Okay, so the first digit we get is digit 1. What does that mean in our simulation? She made the free throw. Okay, so the question is, when do we stop? After 5 digits. She's shooting 5 times. So she's going to shoot those 5 times. We're going to stop. That's one simulation. So we are going to stop after 5 digits. And then the next question, are we going to use replacement? So now that we got a 1, are we going to allow a 1 again? Yeah, that 1 does not represent a specific item. It represents making a free throw in general. So we're going to stop after 5 digits, and we are going to use replacement. Okay, so then, here's what we got to figure out. What do we care about that trial? So when we get this first set of 5, what do we care about? How many makes, how many misses? Do we need the number that she missed? Like, what are we going to record? So here, misses 1 time. Do we care specifically that she missed once? What do we want to know ultimately from our trial?
She missed less or more than 3.
Did she miss at least 3? That's all we care about. So we're going to use replacement, and then we are going to record if the number of misses, this is digits 7 through 9, is at least 3. This is one trial. Repeat for many trials. That is the part, those last 2 sentences is what most people forget. Most people forget to denote that this is one trial, and most people forget to say repeat for many. Oftentimes I will tell you how many trials to carry out, but in this case we're just going to do it a bunch of times. We're not actually going to, but this is the first part of what you have to be able to do, is design the simulation. The second part is actually carrying it out. Do we have any questions on the specificity here or why I said any of the things that I did? Okay, we're going to carry out a few trials and then answer the question. So she misses less than 3. I'm going to make myself a little table. Misses at least 3. Like we talked about before, when you use this table, you need to mark on it so that I can carry it out, so that I can see your reasoning. So here are our first 5 shots, and we see she misses once. So that's less than 3. And then our next 5. Again, she misses once. And then she misses once again. And then this next one, kind of crazy, she misses twice. Are we okay if I just stop there? You follow what I did? Yep.
What does the 101 and 102 mean?
Just the line number.
Okay.
So if you were using a table, it just helps you to find what line to start on better. Okay, and then we need to make sure we actually answer the question. So we would say the probability that she misses at least 3, that happened no times at all. So we would say 0 or very small. Why do you think I put or very small rather than just leaving it at 0?
We didn't finish, so she could have.
Well, we didn't finish. What else?
Just didn't do a lot of trials.
We didn't do a lot of trials.
Anything's possible.
Anything is possible, right? 0 means it's not possible. This is. It is possible. This is definitely not enough trials. Ultimately, what you would probably do in a simulation like this, like real life-wise, you plug it into a computer and have the computer do it for you. And you just hit a button and then the computer will run 1,000 simulations. Nobody actually does it by hand. Questions for me? That's all of the notes. We're going to do another example or two, but that is what your homework is. Any questions before I give you one to try? Okay. If you go to the next page, this is the one that I'm going to have you do. A certain cereal company decides to have a promotion in which it will pack a toy in each box of cereal. There are 6 different toys available. What we want to know, and what most parents will want to know, is how many boxes of cereal will one most likely have to buy, on average, to make sure that one obtains all 6 toys. Okay. The caution that I'm going to give you is most people have an issue with connecting the reality of what this looks like to a simulation. So in a minute, I'm going to have you with your partner write out your simulation and start at line 107. What I'm going to ask you to do is discuss before you start writing, real life, what does this look like? If you're the person going into the grocery store and buying these boxes of cereal, what would that look like to you? And then I forgot to mention, do we need to use all of the digits? No. When we did a simple random sample, did we? No. No. So you don't need to use all 6 or all of the digits. You can, but you don't need to. Okay. I want you to take like 5 minutes, maybe 6 minutes with the person next to you, design a simulation, and then if you have enough time, carry out a few trials, please. Okay, so we're going to start talking. I'm going to show you my answer in a minute. In the past, the biggest issue students have had is determining whether or not to use replacement. What do you think? Replacement, yes or no, and why?
Yes. You get the same
Yes.
twice.
Okay, so replacement, or using replacement, if you get the number 1 and the number 1 again, it just means you got that same toy again. Your design might be different than mine, but it'd be a similar idea. I only use digits 1 through 6, which were the 6 different toys. Each number, though, represents a different toy. Please make sure that you said ignore 0 and 7 through 9, or 7 through 0, either one. We should be using replacement. You are going to stop after at least 1 of each digit is obtained. So 1 trial is complete when you've gotten all 6 toys. This is what I expected. Maybe we forgot to denote clearly this is 1 trial. And then for each trial, you're counting the number of boxes that were opened. You should mark on the table so that I understand what's happening. So what I did is I circled every new toy and crossed out the numbers I wasn't using, and then I put a vertical line to denote the end of the trial. So then all I cared about is how many boxes did I open. So the first trial, I had to open 10 boxes to get all 6 toys, and so on and so forth. And then I didn't ask you to actually do this, but you wanted to, if you had to, estimate the average number. So take the average of those 3, it's going to be about 11.67 boxes. How accurate do you think that 11.67 is?
Decent.
Decently, I mean,
No?
Decently not accurate.
Semi.
at all.
Why is it probably not very accurate?
Because if you're buying from the same store, they probably just got all the same toys.
Okay, I love the personal experience you're bringing to the table. Can we have some stats reasoning as to why this is probably not very accurate? Can't open 0.67 of a box, sure. What else? It's related to the law of large numbers. Only 3
Only
trials.
3 trials. Good
We
job.
didn't do very many. So in all likelihood, that's probably not going to be accurate.
It's not that bad though.
Well-
Like each week you just have a box of cereal.
Do you know how expensive boxes of cereal are now?
What, like $3?
Box of
4
cereal.
months of cereal.
Yeah.
That's
not an actual number.
Yeah.
How much is a box of cereal? you say?
That's a lot of food though, if you think about
Like
it.
$4
Like a
maybe?
box of
$5?
Cheerios?
If it's
think
good
about this.
cereal?
What about this? What if I think I could live on a box of cereal a day? If I live on eating $4 of food a day,
Cheerios,
that's
they're good
pretty
for you.
Well,
pretty
good
good.
for you.
That's
I don't think
not
all
fair.
of
You
us
probably
would.
wouldn't be like energized.